The continuous need to develop industrial infrastructure, to expand oil and gas distribution networks, to modernise and construct new railways, to build better and more efficient ships, aircraft and cars will ensure that the market for high-performance secondary steels continues to grow and expand around the world. The global demand for this secondary steel, particularly driven by the growing economies of China, India, Russia, Eastern Europe and South America, has placed a premium on efficient production. Steel production is a highly energy-intensive industry, with an ever-increasing emphasis on lowering energy costs, reducing greenhouse gas emissions, ensuring environmental compliance and improving production rates. As demand increases and new market opportunities open up, attention is now being focused on the use of vacuum in the steel-making process. Vacuum is used in steel degassing, an essential process in secondary steel making for these high-performance products, which enables rapid and effective removal of large volumes of dissolved contaminant gases such as hydrogen, nitrogen and carbon monoxide from the liquid steel. The result is higher quality, higher strength, higher value steel. Historically, steel degassing has used steam-powered vacuum ejector systems. These systems consume large and expensive amounts of steam generated from fossil fuel-powered boilers and also require substantial routine maintenance. Compared to steam ejection, dry mechanical vacuum systems offer major savings in terms of running costs, very significant reductions in greenhouse gas emissions, reduced maintenance costs, smaller installation space and increased operational flexibility. For degassing small to medium production batches of liquid steel, typically from 20 to 200 tons, two vacuum processes are used. Vacuum degassing, or VD, for standard steels, and vacuum oxygen decarburization, or VOD, for stainless steels. Over the last decade, Edwards has become the leading global supplier of dry mechanical vacuum pumping systems for these processes, installing in excess of 100 dry pump steel degassing modules like this one around the world. Such dry pumping systems can deliver operating cost savings of around 80% compared to conventional steam ejector systems, and at the same time provide savings in CO2 greenhouse gas emissions of up to 90% or even more. Reducing these emissions by this amount in producing 1 million tons of steel can save over €350,000. But most of the quality degassed steel worldwide is produced by another method, the Ruhrstahl-Heraeus or RH process, which is typically used to degas larger batches of steel production between 150 to 400 tons. Up until now, the sheer size of RH plants were considered too large for dry mechanical vacuum pumping systems, and large steam ejector systems have been regarded as standard. But now the huge potential for applying dry pumping technology to this process too is being recognised. The RH steel degasser uses a large vacuum chamber with two snorkels at the bottom. The ladle of steel is offered up, vacuum is applied to the chamber and the steel rises up through one snorkel and flows out of the other. This circulation is created by injecting argon into the rising side to make the steel more buoyant. Injecting argon also helps carry away the dissolved hydrogen, which needs to be removed from the steel. In 2008, there was a major step forward when Edwards won a contract in China for the world's first application of dry vacuum pumps to an RH degassing process. It's the world's largest dry mechanical vacuum pumping system and Edwards' largest ever single order in the metallurgical market. And it's just been successfully brought on stream.
This new RH plant can degas 230 tons of liquid steel in each batch. And the Edwards vacuum pump system has a world-beating peak pumping capacity of around 1 million cubic meters That's about 400 Olympic swimming pools every hour. For both economic and environmental reasons, the customer specified dry pumping technology for their new RH plant. Edwards modular vacuum systems were selected because of their global reputation for suitability and robustness in the harsh steelmaking environment, and also because of Edwards' proven track record in steel degassing for both the VD and VOD processes. For this 230-ton RH, Edwards has supplied 18 steel degassing super modules, the front stage of each comprising twin mechanical boosters of 40,000 cubic meters per hour. This dry pumping system provides the Chinese client with substantial energy cost savings compared to a traditional steam ejector system, a consistently high quality of degassed product, reliable push-button plant operation, and a big advantage in lower cost of manufacture. And of course, the environmental benefits of reduced water effluent and a significant CO2 emission savings are there also.
The successful commissioning of the world's first dry-pumped RH plant and the excellent resulting product performance have opened the door to a new era in dry vacuum pumping for large-scale steel degassing. A tremendous global market opportunity for Edwards with huge economic and environmental benefits for future steel plant operators. And a major breakthrough in the application of green technology for now and the future.